The following is a production of Woods Hole Oceanographic Institution.
I was in Belize trying to count the number of grouper larvae. The people that I was with were diving, but at that point all I could do was snorkel. And it was about that time that I decided I needed to learn how to dive because I wanted to be able to see, deeper down, not from the surface so much, but deeper down and see what was going on underneath it all.
In a way, it's a little bit different from what we think of at Hui, because we think of big ships and big instruments and vehicles and submarines. But there's a lot of work that can be done and is done where a human underwater with the full manipulative capability of their hands and their eyes is a much more useful way to do the work.
Down in Panama, we will be using a new type of system called scuba cop, which scuba is the obvious, but cop is chemical optical platform. With the scuba cop, the diver becomes the propulsion and guidance system for a suite of sensors very similar to what human-occupied submersibles like Alvin uses. And that system we will be using to survey and map sections of the reef there. And our hope is to develop a computerized 3D reconstruction of the reef. And it's in an area where it would be difficult or impossible to run a robot. It's a fairly high current environment. There are steep walls and overhangs. And so the ability to get in and map these areas is really still limited to what a diver can do.
I'm really interested in looking at the migration of fish from their juvenile nursery habitats in coastal wetlands out to the reef as an adult. So we spend a great deal of time hand selecting individual fish, perhaps after they had just fed, or fish that I notice interacting in a particular way with another fish.
Robots are terrific, but not in this sense. They're not fast enough. They don't respond fast enough. It would just be a nightmare trying to catch an individual fish with a robot.
With the clownfish, for instance, we're actually collecting adult clownfish on anemones. We're taking small fin clips that basically give us a DNA fingerprint, and so we're tracking not only the adults through time, but we can also then trace where the progeny of those adults are going by parentage analysis. The fish are collected off the anemone, but then the fin clip is all done about a meter away from, or less from the anemone, and then the fish are put straight back onto the anemone, so we can do it with a minimum of disturbance to the fish. So there are insights that you get by being underwater in that environment that you simply would not get if you were restricted to the surface. It allows us to be in their environment, and that's beneficial, I think, certainly for the animals that we're studying. But I think it gives us a little bit of a feel for the environment as well.
To learn more about Woods Hole Oceanographic Institution, visit us on the web at www.whoi.edu.